I'm Brian. I own Crowl Construction located down in Keene. Can everybody hear me okay? If I walk around a little bit. I don't know if I'm going to walk or if I'm going to hide, so you have to bear with me a little bit. Just to tell you a little bit about myself, I moved to Keene in 1999. I had gone to art school in Pennsylvania and graduated with a Bachelor's of Fine Arts and had aspirations of going on to be an art professor or a teacher or a professional artist and things like that. And that plan didn't really pan out so well. And I was just kind of hanging out, being a rock climber and not really doing much of anything. So I literally packed up my truck and moved to the Adirondacks with a little bit of money in my pocket and a truckload of carpentry tools, because that's what I had always kind of done as I was going to school or not doing anything really. And just decided to fulfill my dream of moving to the Adirondacks and becoming maybe a professional rock climber and guiding and living this wonderful life. And about 2 weeks after I moved here, I realized that that wasn't going to happen. It never would happen, and I ran out of money, and I needed a job. So I got a job with a local contractor, and I worked for about 7 years doing some really nice projects with another contractor, and then started my own business about 10 years ago. And when I started my own business, I realized that I really didn't know as much as I thought I did. You know, like when you're working for somebody else and you're under somebody else's wing, you really kind of don't understand what the real contracting world is like. You think you do, but you really don't. And then all of a sudden, it's all on you. You're responsible for everything. And you really figure out in a hurry how much you don't know and how much liability you're exposed to. And I knew that I had to kind of figure that out pretty quickly, because I could build a house with one hand tied behind my back, but I didn't know anything about running a business or anything that was involved with that. So I started going to all these different classes and seminars, JLC Live and NESE and Affordable Comfort and all these different things to kind of educate myself. And I started to realize, okay, well, one, I started to run my business better. So I started to grow, I started to make money, all those good things that you do this for in the first place. But I also started to learn about this thing called building science and the way that these buildings really should be put together, because it turns out that even though I was under the wing of a lot of really great guys and really skilled carpenters, it's not that they didn't know what they were doing, it's just that they didn't quite know what they were doing. And it took going out into the real world and talking to people who were scientists and people who were kind of really into this stuff to kind of get your head around that. And you kind of started to realize, okay, well, you can't do things now the way your grandfather did it and the way like several generations used to do it, because it's just not going to work anymore. And so I got really excited about that, did the green building certification, realized really quickly that it didn't matter who I said I was a certified green professional, they didn't care. And so I was really excited about that, and then when I told everybody, they were like, we don't really care. It was kind of like a little bit of a fad thing, and people, they didn't get nearly excited about the green aspect of the building so much as they did their big stone fireplace that they wanted to put in their house. And that was just the reality of it. So I found out very quickly that because I was passionate about this, I just wouldn't tell them about these things if they didn't care about it. If they cared about it, great. If they didn't care about it, I wouldn't tell them. And I began kind of sneaking into my protocol all the things that I learned about that made houses better. And you know what? If they didn't know it, who cares? At least I could sleep at night, because I knew that I was building the very best house that I could build. And as long as there wasn't like a really substantial cost increase, or people weren't really up in arms, it's kind of like, it all kind of worked out. They were getting a high quality house. I was doing techniques and using methods that made me sleep well at night, and everybody was happy. I got really lucky when Melissa and Dominic came to me. In fact, when they came to me, I feel like there was a time period when I was kind of like, oh. I remember talking to Dominic and trying to contain myself, because it was so exciting to actually have something that was the culmination of all these years of kind of getting into this stuff that was actually kind of come to fruition. And eventually it did. And so here we are. So this is a talk. And I just want to say thanks to both Kevin and Jesse for really great presentations. Hopefully this is kind of a continuation of that, because the first one talked a lot about the balance of the planet and our lives and our houses. The next one talked a lot about the teams involved and the science behind these buildings. And this is going to go one step further and be more of a nuts and bolts talk about how we actually put this particular house together. There's not going to be a lot of data. So if you're looking to see a lot of like pie charts and things like that, question? Here, this way? Just right here? Okay. All right, I'll try to stay within this circle here. So, sorry, I lost my train of thought now. Okay, so, and then Jesse talked a little bit about the team. This is going to be nuts and bolts. There's not going to be a lot of data per se, a lot of pie charts. I apologize. A lot of my answers to your questions eventually could be, I don't know, or it depends. Because the way that we put this house together is just one of many, many, many ways of putting houses together. So you may see things up here that you don't agree with or you don't think is the best method, and I just try to ask everybody that, you know, we kind of work back and forth, and this is the prescribed method that this particular house decided to go with, and it might not necessarily be, you know, what you've seen in the past or what you even agree with as far as it being the correct way to put something together. So this is the Eisinger NetZero home. It was completed fall of last year. I think that Melissa mentioned the designers over in Vermont, Nitrux Cullens. Lee Grutchfield and Rich Jimenez were the lead designers who worked with everybody. As Jesse spoke of in his presentation earlier, foundation for a successful project has a few different elements to it. The clients, who have a clear understanding of their own goals and visions, the design team, experienced in high-performance homes, and the builder who understands modern building science and can put together all the materials and design principles correctly. It's just a coincidence that the builder was kind of like the longest explanation there. I don't really find myself more important than any of those other teams. Nuts and bolts of kind of the package of the house, the R values that we used were 15 in the slab, 35 in the basement walls, 43 in the framed walls, and well over 60 probably in the attic. And all the windows were actually, one of the vendors is here today, the Marvin Integrity line of windows. They're triple pane series windows. Almost, I believe all of them were casements. You know, the thing that I think is important for people to kind of get past is that, you know, building a net zero house is just like building any other house, to be honest with you. And I think that's one of the reasons that I got so excited about the prospect of doing projects like this, because when the more you learn about it, the more you realize it's like it's not hard. Like really, it's not hard to do. You're just basically taking everything that you already know and you're kind of moving it up the ladder ever so slightly. Sometimes you go up one rung, sometimes you go all the way to the top of the ladder. And you can pick and choose what you do, but it's super easy. You can do it. There are systems, you do have to kind of have an understanding of the entire system so you don't cause problems down the road. But really, it's not that difficult to do. I'm actually excited that the codes have gotten just stricter this fall because it's kind of starting to trend in that direction. So we broke ground in the fall. We're getting a really late start. I'm just going to go through, and once again, this is going to be kind of nuts and bolts, so you're going to see lots of pictures of lots of different elements of the building, and I apologize, a lot of my images are not crystal clear, but that's what happens when you run around the job site with a cell phone packed full of dirt in your tool pouch and you're kind of clicking off pictures of what you've been doing over the course of the day. Sometimes it's filled with snow, sometimes it's filled with dirt. Pretty typical, you know, construction, regular foundation footings. You can see we've got, I gotta remember which buttons are which here. You can see we've got these little kind of footers outside or outboard of the strip footers for the foundation, which you'll see what those are all about a little bit later. The first step, and this is the first place that we got into kind of like, okay, well, how are we going to figure this out and how are we going to start putting all these components together, was applying all the rigid foam to the exterior of the entire house. So the whole house has 4 inches of foam basically that goes from the footer all the way up to the roof plane. And this was our, kind of the first phase of getting this done. When we got into this project, the thing that happened really quickly that was going to keep going throughout the whole project was saying to ourselves, well, how are we going to do this? Because you know, we've never actually built a house with all these components put together in this way. And so a good example of that is, well, how are you going to attach all this foam to the foundation and have it be simple and have it be fast? And we wound up finding some plastic cap, like 5.5-inch fasteners that we could use to do this. But again and again, as we went through the whole project, we'd kind of come up to something that came along in the plans, and we'd have to pause for a moment and try to figure out, okay, well, how are we going to do this? First of all, how is the team going to agree that we actually execute this? And where are we going to find the products, and what products are we going to put together that make this happen? Sometimes it was really simple, and it happened really fast, and other times we struggled with it, and it actually took a while to work out. What you see on the outside of the foundation is concrete columns. And the architects did not want to try to attach all the decks, which is actually decks that go almost the whole way around the house. And they didn't want to attach decks and try to figure out some way of through bolting to the, through the foam and so on and so forth because there was so much exterior foam. So we actually poured these secondary piers against the foam that would support the decks once that they were built. So once again, we've got really typical, no-brainer construction techniques where we're putting the perimeter drain in, we're putting the pipe in, we're covering it in stone, wrapping it in fabric. It's all basic stuff, and then we've got other elements that we're kind of figuring out on the fly, trying to make happen and keep the architects happy and keep the project kind of moving along. Just another shot of the outside of the foundation. We put all the foam on, 2 layers, staggered the joints, and then kind of a belt and suspenders approach to everything, which you're going to see through this whole project. We basically took a 3M weather flashing tape and taped all the joints, taped all the fastener holes, things like that, right from the bottom up. In the basement, we did 2 layers of foam, 1-inch layer and a 2-inch layer. In hindsight, I started doing 2 layers of 2 inches for all of these because it just makes sense. You're spending a little bit more money on foam, you're going up in R value, and you're basically installing all of the same number of boards, doing all the same labor, and it's a really easy way to boost your R value in the basement. Once that's done, we do 10 mil stego and tape all the joints, make sure everything's sealed up really well before we pour the slab. Once that whole phase is complete, then we start framing, and this is where we, not that we weren't having fun the first time around, but we started kind of moving a little bit faster now because once again it's just a conventional house. So we have the deck, we start framing, and here's where things kind of roll along because this is something we've always done. There's nothing weird here. There's no pausing to say how can we figure this out and how can we put all these components together and make them work without making a mistake along the way. And so pretty quickly the framing starts to kind of roll along. Again, as you've seen in a couple of the other presentations, using the zip wall and the tape is a really great system for making things airtight. Yes, that's December 23rd. Still pouring footers and doing concrete work. We were blessed with an amazingly mild winter for this project. As Melissa said, beautiful site, nice views, great place to work. And eventually, once the roof structure is finished, the next thing that we need to do is start to prepare the outside of the envelope, which is applying all of this foam. And once again, just kind of figuring out the components and talking with the architects. The architects did a really good job in communicating with both Dominic and I about their wants and wishes. And before the project even kind of got off the ground, we would have these little teleconferences where the architects and Dominic would go back and forth and kind of decide like what systems they wanted to use. And then they would come to me and they would say, well, what do you think about this? And what have you done in the past? And it was a really good relationship because there was a lot of back and forth between all of us. And there were things that I presented that maybe they weren't super comfortable with. There were things that they presented that I thought was a much better idea and a big improvement on what I had done in the past. So that whole back and forth thing worked really well, and it was really great. As a builder, or anybody in the trade, I think that there tends to be a little bit of a push and pull between the builders and the architects. I've experienced this even way back when I worked for somebody else. The architects like to make sure that everything's done the way that they want it to do. The builders kind of want to ignore the architects and do things the way they want to do. And in the end, people start butting heads, and sometimes there's hurt feelings, and and it tends to not necessarily be a great way for people to work together. And it's been both good and bad in the past. On this particular project, the folks who designed the package of the house overall did a really great job, and in the end, everything was pretty successful. So here we are doing the exterior insulation, and we start applying it over the zip panels. The window bucks that you see, because the walls become so thick, we actually build out the framed walls. Everything is just stick frame, 2x6, 24 on centers. kind of what you would call advanced framing, I guess is the term that most people would refer to when it comes to this. And we apply 2x10s to the window frames to build everything out, that 4 inches to make up for the foam that's on the outside of the house. And we pay a lot of attention to detailing all of this with the flashing tapes, making sure that everything is very durable around the window bucks and moving into the insulation. Again, I guess just kind of let's talk about how we applied all the foam. The first layer we put on, basically just cap nailed it on. It was all very tight. Second layer went on, and we did it in a different orientation with all the joints staggered so that there weren't any parallel joints through the entire structure. Again, really doing belt and suspenders. We gapped all of the sheets on the second layer, about a 3/8 of an inch, something like that. And then we spray foamed in between all the sheets to make sure that everything was sealed up really well. And then, of course, there's that little bit of back and forth being like, oh, well, what's the better protocol for doing this? Do you have to tape it at all? Do you have to spray foam it at all? Do you just put it on as it is and call it good? What if you spray foam it and the foam cracks over time? What if you tape it and over time the adhesive fails? And so we kind of approached it as like, well, let's just do everything. And if you do everything, then maybe you don't have to worry about it as very much. Some people would say, well, that's not really cost effective. But for a little bit of time and a little bit of money that you put in materials, I kind of feel like the belt and suspenders approach is going to give you the best possible product in the end. And this is just a couple detail shots. You can see how everything's kind of put together. We treated the window openings just like anything else once we got to the point where all the foam was on and the window bucks were in place. We basically just kind of, we used to use metal pans for this, flashing pans, and we found that we had a lot of problems air sealing around those metal pans. And we also found that the metal became a direct conduit from the outside to the inside. And we actually had a lot of problems in other houses with the condensation on the insides of those metal pans, and we had air sealing problems and things like that. So we got away from using the metal pans, and now we just take a grinder and slope the seal a little bit, flash it with any version of the all-weather flashing tapes, and just kind of go from there. A big point of contention that we kind of ran up against, and I guess it wasn't really a point of contention, but that we went back and forth about a lot was, again, doing the exterior of the house and relying on adhesives of these tapes and so on and so forth for a lot of the flashing intersections. And the conclusion that we kind of came to is that if we spend a couple $100s on the Typar, we could wrap the whole house in Typar, and we could still do mechanical, or I guess you could say lap flashings on all the really important areas of the house. So we weren't relying on the adhesives or things like that, and we all kind of had a little bit more of a peace of mind that there was actual house wrap, traditional house wrap, kind of lapping over your head flashings of the doors and the windows and the skirt boards and the deck flashing and everything else, which I kind of feel like it just kind of makes everybody sleep a little bit better at night. Once again, some people would maybe think this is a little bit of overkill, but again, belt and suspenders, in my opinion, not a bad way to go. Since then, and I was talking to some of the fellows out at the SIGA booth, we've gone on to some more, I guess, advanced products on the current project that we're working on. On the left, you see Prosoco wet flashing that's applied to the window opening. Great product. Can't say enough about it other than the fact that it is a little expensive. And then on the right, the continuation of that with a European Zola window where we're using the SIGA tape, which is actually a weatherproof but permeable tape to allow moisture to escape from the window opening if it ever does get behind there. So, and once again, this drives my guys crazy. They love working with me and for me, but every single project we do, I think they get a little frustrated sometimes because they never know what they're supposed to do next, because we never do the same thing twice, which is frustrating for them, but it really speaks to the fact that we're constantly trying to be a little bit innovative and use the new products that come on the market and do something a little bit better than we did the last time, which is good for the buildings, but it makes my guys really frustrated because they never really know. They never do anything twice. So once we move on to this point, it's starting to look more and more like a normal house. From the outside, if you were to walk up to it, you probably wouldn't even realize what's going into it at this point. When we build the decks with this much foam on the outside of the house, you can see where those piers come into play now. So what you see right here, this is not a great photograph of this detail, but this is the post that is sitting on the pier that is outboard of the basement foam. And it's basically just a completely freestanding deck that is simply, kind of just attached to the house in a very superficial way, I guess you could say. And we have drainage blocks behind the deck beam to allow water to drain behind the deck. And then the entire surface, top surface of the deck is covered again in the 3M flashing tape so that we get maximum durability. That covers all the beams, all the joists, all the blocking, the carrying beams that are kind of down below the decking that you can't see as well. So the siding presented a little bit in the problem because once again we put all this foam on the outside of the house and now we have to figure out how we're going to attach the siding. In Melissa and Dominic's case, we were going to do a vertical board and batten siding. And we knew that we could just attach furring strips to the house, but none of us were really psyched about the fact that we were going to do the furring strips and then we were going to block the drainage plane as we did this. And I was interested to see in Kevin's show the slide where they were using the roofing product that was all the furring strips with the notches built into them. That was a pretty good idea, but we kind of went one step further and we used the product that was made by CoreVent that we actually applied to the back of the furring strips. It's like a drainage product. It kind of looks like a piece of cardboard, but it's made out of plastic. And we apply that to the back of the furring strips and then attach the furring strips to the house with long screws, and it essentially creates a complete drainage plane and drying plane, but it actually allows water, if it does get through there, to pass behind the furring strips and all the way down and out the bottom of the building envelope. So once again, systems that we've never done before, it takes a while, a little head scratching to kind of figure it out. Eventually, a little thinking out of the box and playing around with a few ideas, we kind of solve the problems. And it's kind of like a little stutter step. You kind of just start to get into it, you just start getting the siding going, and take a step back or two and figure out the system and how to do it properly. And then you're off and running, and it's kind of just like pretty straightforward construction again. The architects had planned to have the foam go all the way up into the gables. We decided not to run it up. We ran it up a little bit higher than what the cellulose would be in the attic, and then we padded out the gables to meet the plane of the rest of the house, so the siding would all be in one plane. We also, what you see right here is our local code enforcement agent was going to allow us, as long as we had access to the attic, he wasn't going to make us put like a scuttle hole on the inside of the house because we didn't really want to deal with having to try to air seal that and try to make it as tight as possible because it's a real pain. And so he allowed us to do outside access to that particular space. There's no storage or anything up there. And so we access through this panel right here, which again was built out and sealed fairly well. But we don't have a scuttle hole in the attic allowing all that warm air that we spent all this time and effort to make warm going up into the attic area. Once we have the outside pretty well under wraps as far as all of the quote-unquote NetZero detailing of this place, we move to the inside. And because it doesn't just stop where we did the exterior work. We're going to blow cellulose into the attic plane, and this is something I picked up from gosh knows where, some seminar or somebody else's slideshow that I decided to copy, where we basically get rid of the traditional proper vent and we make our own out of half-inch foam. And this adds a little bit of R value to the gables. It really gives you a lot of venting, like we're using the whole space of the 22-inch bays. These are just trusses, 24 on center. And it allows you to run it up pretty far so you're not going to worry about having your installer come and blow cellulose into your proper vents and just jam it all up and kind of short circuit the whole system. And it's really, really quick and easy to install. So it's not nearly, I wouldn't say it's as fast as stapling up the proper vent, but it's a much better job. Once we have that taken care of, this slide's a little bit dark, but we go through the whole upstairs. We haven't framed any walls upstairs. Melissa and Dominic's house was kind of nice because it was very simple floor plan. There weren't even a lot of walls upstairs to frame at the end of the day. But we basically left all the walls unframed upstairs. We applied the same exterior product, the zip wall, to the bottoms of the trusses, and then taped and sealed everything. And by doing so, we created a nice platform onto which to blow our nearly 2 feet of cellulose. and have a continuous, layer that we could put our sheetrock on in whatever orientation we really wanted to, depending on the size of the room and the length of the sheetrock. And then we came back and built the walls underneath. And so now we have a continuous layer on the ceiling that's completely air sealed. Again, belt and suspenders. We tape all the joints. We go back up into the attic after that's done. This is a couple shots of the cellulose after it was done. We like to build a raceway down the middle of the trusses so that you can access it and get from point A to point B without having to put your snowshoes on and wallow through all that stuff. And you can see here how the proper vent that we made comes up nice and high, stays above the level of the cellulose. Kevin this morning touched on the fact that as these houses get tighter and tighter, it's going to develop some problems. And I really, really agree with him. I feel like if you don't know how these houses are going to act and don't anticipate that, you're going to get into trouble, not only like with the occupants and the indoor air quality that these houses might have down the road as they are lived in over time. And again, just like Josh said, that's has to do with the occupant use and how they live and how they work and act in the houses, but also during construction. So this is a shot of the ceiling after we turned the heat on and before we blew the cellulose in. And you can see the massive amount of condensation that we got on that ceiling plane as the building started to kind of dry out from the inside, but we still had cold surfaces. And it really is not a big deal. It's a little shocking when you walk in and you see things like this, but we use commercial dehumidifiers when we get to this point, and we either have the HRV hooked up and we're running that to kind of dehumidify the house and draw the moisture down as the heat comes on, or we are running our dehumidifiers just into the spaces and kind of drawing down the moisture as we turn the heat on. Just a shot up in the attic, making sure that we seal around all the wiring penetrations. On the exterior walls, again, I saw this on Jesse's project down in near Albany there. Airfoil boxes, we use airtight sheetrock technique where we caulk different aspects of the sheetrock before we put it on. These particular outlets make it very easy to do that. Little shot of caulk around the outlet itself. You can spray foam around the wires. Makes for a really nice product in the end. And we basically just infilled all the cavities with rock wool. We did all of our rim insulation in-house with rigid insulation and polyiso foam. And once again, eventually you kind of get to the point where, you put the sheetrock up, tape it, paint it, start to do the trim. Looks like just like any other house, unless you were really kind of pick up on the fact that the trim on the inside of the windows is a lot deeper than most homes. You would never really know kind of what we did here. The blower door testing, we do this throughout the entire process. The nice thing about putting the zip wall on the ceiling is that, after the windows go in and even before the insulation was finished and the project is really, really far along where you're already insulating the insides of the walls or you have your sheetrock hung or who knows what, you get so far along, you really don't know if you've missed anything. When you put a blower door in and you do the testing when you're just at the framing stages, you can walk around and you can find fairly quickly the little places that you missed. You can find the wire penetrations that go from the attic down to the second floor that you missed. You can find the spots where your electrician came along or your plumber came along and drilled a few holes that you forgot about or you didn't know that are short-circuiting your system, and you can fill them up. So it's a great way to diagnose the house, find out just how good a job you did, and go through and start fixing all the little leaks before you even start to move into the insulation phase. We pay attention to a lot of stuff. So we're talking about air sealing the house, trying to get it as tight as possible. And does anybody have any thoughts as to why this photograph is up here? What could a picture of the service have anything to do with air sealing the house? Exactly. So we've got conduits that connect the outside air at the meter directly to the basement. In this house, I think that we had 4 or 5 of them total of different sizes. We had one for the main power, we had one for communications, we had one for solar. We had another one for solar that went from the garage to the house. So you can see how pretty quickly, that starts to add up. And it's a direct path that goes from point A to point B, from the inside of the house to the outside of the house. So after we did a couple of the blower door tests and we got a little bit further along, we actually realized that this was a path that the air was flowing through. And we went into the basement and we pop off the covers of the UB connectors here, and we just spray foam around the wires and make sure it's sealed up really well. And it's another problem solved. It seems nitpicky, but really the devil is in the details. And the tighter you make these places, the less places there are for the air to get out of the house. And it concentrates. You can almost think of it as like when you blow up a balloon. My kids do this all the time. It drives my wife crazy. And they hold it right up to your face, and you don't tie, and you let the air out of it, and it's going, and it's there's a little bit of juice squirting out everywhere, and it's like really loud and disgusting. All that air is trying to get out through that little opening. And it's the same way with the houses. It's like anyone who's ever done this kind of stuff with a spray foam or these tight houses, and there's a leak someplace in the house, and it's -10 in the middle of winter, and you walk around and you see icicles popping out of the siding, or at the bottoms of the doors or the windows and things like that. That's the reason why. And so the more that you can kind of control all those little places that moisture is getting out, the less problems you're going to have in the long run. Okay, I'm almost done here. Yep. Couple minutes. Okay, so I'll run through these last ones pretty quickly. This again, this kind of gets back to some of the green building aspects. Once we sheetrock, we kind of hide stuff in the walls after it's been secured to keep more of the trash out of landfills. We reuse a lot of the scraps. Here we took all the scraps that were left over from sheathing the entire house in the exterior foam and basically cut them all up and put them in the garage slab. Got rid of almost everything. Completely usable. When the house was finished, we installed a Venmar HRV with a HEPA filter in the basement to help with the indoor air quality and get rid of the pollutants in the house. The Venmar actually has a really nice control system. It's really simple, and we have controls in the timers in the bathroom that when you turn them on, it boosts the HRV to high for a certain period of time to help exhaust the pollutants in the bathrooms. Heated the house with an air source heat pump. They decided to just keep it simple and do an air-to-air system. So that's our heating and cooling. And after we were fairly well along, they added the PV to the roof, which from the sounds of it is producing quite nicely. And at the end of the day, a pretty little house. And without my talk, you might not know exactly what went in to build it. So that's basically it. I guess we might have the size of the house is about 22,000 square feet. Yeah, it's about 2,000 square feet with a mudroom.
If you count the porches.
Mm-hmm. Mm-hmm.